Hello everyone and welcome to the module PN junction diode and its applications. Here we are going to see the last video of the module and it is about the application of a PN junction diode as a full wave rectifier. So we are going to explore the definition of full wave rectifier, its circuit, the working of full wave rectifier and the full wave rectifier with capacitor filter. And we are also going to compare the smoothing in full wave DC output with that in half wave rectifier. So what is a full wave rectifier? A circuit employing two diodes whereby both conduct, one only in the positive half cycle and the other only in the negative half cycle of the AC input voltage, is known as full wave rectifier. The circuit is shown here. You can see it employs two diodes. The diodes are named as D1 and D2 now. This is a step down transformer and this is the AC input voltage supplied through a source. The circuit is again shown here and the input and output voltages are shown graphically. The input is supplied from a transformer with a center tapped secondary winding. During the positive half cycles of the input AC voltage, the diode D1 is forward biased and the diode D2 is reverse biased, whereas during the negative half cycles of the input AC voltage, the diode D1 is reverse biased and diode D2 is forward biased. So, coming back again to the positive half cycles of the AC input voltage, when the diode D1 is forward biased and D2 is reverse biased, the current IL will flow through the diode D1, the load resistor RL and the upper half winding of the secondary. The output voltage VO is developed across load resistance RL. During the negative half cycle, what will happen? The diode D1 will be reverse biased, diode D2 will be forward biased and the current now will flow through diode D2, the load resistance RL and the lower half winding of the secondary. So, the direction of current flow through the load resistance RL is same in both the cycles. Hence, the current IL passes through the load resistance and produces output voltage V0. The output of the full wave rectifier consists of a continuous series of positive half cycles of AC voltage. Here you can see in this graphical representation the input and output waveforms. This shows the input when the D1 is forward biased and this shows the input voltage when D2 is forward biased. So, you can see when D1 is forward biased, you get the output from D1. When D2 is forward biased, you get the output from D2. So, there is a continuous output obtained in the full wave rectifier. Since the output is obtained from both the half cycles of the AC input voltage, therefore, the circuit is known as full wave rectifier circuit. The pulsating DC voltage obtained from the rectifier can be again smoothed out with the help of a capacitor filter as shown in this diagram. Here you can see that the capacitor is connected in parallel with the load resistance RL and it can smoothen out the output voltage obtained from the full wave rectifier circuit. A stable DC voltage can also be obtained. Here we have a comparison of the outputs obtained in the half wave rectifier and full wave rectifier circuit, and in the lower diagram we have the comparison when the capacitor input filter is used. So, in the upper diagram you can see that only the positive half cycles of the AC input voltage are obtained as output voltage in the half wave rectifier, whereas the negative half cycles of the AC input voltage are suppressed, whereas in full wave rectifier both the half cycles are converted to the output voltage. Therefore, it is known as full wave rectifier. The bottom figure depicts the effect of capacitor filter on the smoothing of the output DC voltage obtained in half wave rectifier and full wave rectifier.